Hi, this is Mohan Indivilla. So, as part of deep learning course, I'm doing the final project on Trump emotion recognition from his speeches. So, being Trump as a president, he always gives the speeches and interviews on the political topics. So, at the end of each topic and his speech, I would like to identify his emotion on the topic. So, to solve this problem, I'm using the Anaconda, Python, Jupyter Notebook, and some of the Python packages. And I'm using the hardware Dell laptop with Intel Core i7 processor with 32 GB RAM. Let me walk through my final full report. And here I'm selected the two dataset. One is RAV dataset, RAVDES, and another dataset is test dataset. In the RAVDES dataset, we have the three set of the files. One is only audio files, another one is audio plus video, another one is only video files. So for this project, I selected only audio, video plus and audio files. Audio and video files are converted to audio by using the Python code. And from test dataset, I downloaded directly from this website through Python program. And I reported that these are the two URLs. And in the RAVDAS, we have the naming convention with the digits, and each digit represents the different values. So I selected here. So then these datasets we need to segregate the based on the emotion, two different emotion folders. So let me walk through the code. So here, this is the first cell is initiating all the libraries required for this project. And this piece of code, it will generate the folders with the emotion names like this in the train input directory. And these are the datasets we already walked through. And this piece of code, it will convert audio plus video of RAVDES file sets into audio files. So in the temp folders. So then I will be copying all the datasets, audio plus converted audio files into final input. So from the final input, so to train input where we created the emotional folders, I'm segregating the dataset using the file naming convention based on the digit numbers. So each digit represents the different emotions. So the files will be segregated across the folders, emotion folders. So once the RAVDES files are segregated, then I'm taking the file count, and this is the file count, like total 2876 files with 8 emotions. Files are downloaded to train input folder. And from test dataset, and this is the URL, and these are the data I have written code, and which will download the files from the based on the each handle. So it will copy to the respective emotion folder. So these handles I identified, I went to this website and I identified each handle, what is the handle range and what is the type of emotion. So once that file copy is done from website, then I ran this code, then it will identify what is that total file count. So the total file count is 5676 with 8 emotions. So this is the sample data set from happy folder and how it looks. And after that, this piece of code is generating the MFCC vectors from the input folders. So this piece of code, it will split the data set into train and test data set with split ratio 80-20%. And here I'm selecting total 40. Yeah, the number of MFCCs are 40 selected here based on I tuned my model multiple times with the different hyperparameters. Then I came up with these final values. So one of the configuration, this one helped me to improve my model accuracy. So this is my final CNN model with ReLU activation. And this is the final model. And here I trained the model with 200 epochs with 100 batch size. So once the training is completed, I saved that model and I validated the model. So you can, from the diagram, you can see the model loss, how it is changing with respect to a number of epochs for both the train and the test data set. And here the model accuracy, you can see, so how it is changing with number of epochs. The both train and test model validation looks pretty closer, and we don't see any huge difference between the train and test data sets. So The total model accuracy, the validation accuracy is 97%. And I developed some of the functions to use for prediction. So this is the one function which will connect to YouTube and download the video file and converting to audio, then again feeding back to the model. And these are some of the function to generate the heat map and the diagrams for MFCC. And this is the main prediction more function. So which will take the file as input and it will generate MFCC and it will model will predict the value, then we'll compare with this. So whenever the respective emotion matches, then it will display the with emotion emoji. So this is, I developed another function. This is to identify the Trump emotion from the YouTube. So this is the place like you will pass the YouTube URL link, then it will download that video file and convert to audio. Then again it will predict back and it will display the respective Trump's emotion emoji. And this code I have written to identify the sample dataset from a test dataset for a prediction purpose. I executed this code, then it will generate this list. Then from the list, I can identify some samples. Then I can use the same for prediction. So here, the prediction I have selected neutral. So then it's able to predict close to the actual values. So, and you can see other emotions, calm. It is also matching to the actual values. And happy, the model is able to predict. Sad, and angry, and fearful, and disgust, and finally, final emotion is surprised. Yeah, it's so the model is able to predict very close to the actual values. So now let me walk through some sample Trump videos which I selected. So let's run this URL. So now I'm feeding this URL to my Trump emotion predict function. So this function is connecting to YouTube and downloading that video file and converting to audio file. And from that audio file, generating the MFCC vector. And then the MFCC vector is feed to the model. Then model is able to predict back that what is his emotion. So here the emotion is he's very happy on this. So I'm embedding the audio file and the respective diagrams, power spectrograms, and this wave diagram in the Jupyter notebook. So let's watch this video and see what is his actual emotion on this.
Will Smith is a really great guy, and I love what he did to the wise guy, got no talent whatsoever, going around doing all sorts of things. So Will Smith, I congratulate you. That was great. Celebrity Apprentice, very, very big success. Very much. The show is just terrific. Next year is how we can top it, but hopefully it's going to be as good. I don't even ask for better. It was a really wonderful season for Celebrity.
So from the video, you can see that Trump is very happy on that to comment on the Will Smith. So the model is able to predict very close to his emotion in that YouTube. So let's test some other video. So let's take this video. So the model is predicting that his emotion is sad on gasoline prices February 28, 2012. So let's open this YouTube and see what is the actual.
Gasoline, Alan, and it's going a lot higher than that, and people are outraged. The fact is, we have nobody in the White House to protect us. This could bring down Obama, but unfortunately, it could also bring down our country. Gasoline and fuel and oil, that's really the lifeblood of the country. That's what we need to work. That's what we need to survive. When we hit levels like this, like we had recently 4 years ago.
So from the actual video, you can see that he's very sad about gasoline prices. So his emotion on this is he's sad on this topic. And I tested some of the other tubes. So You can try this code, and you can try any URL, and it can predict that actual values back. And here the emojis I downloaded from Apple website, and this is the URL to download the emojis. And I downloaded some of the Trump's emotion emojis from Google, and this is the website I can refer you. And these are the files I set up. And the issues I faced here is like finding the English emotion dataset. It's pretty difficult. And finally, I found RAVDAS. With the RAVDAS, I tried with all the three datasets. Then the accuracy was around 10%. Then I removed only video alone, and I tried only audio plus video audio files. Then the accuracy went up by around 35%. Then again, I downloaded the test dataset, and then the accuracy went up a little bit higher. Then I tuned other parameters, and I came up with number of MFCC frames, 40. Then the performance went up to the 97%. And this is a reference you can refer. And thanks for watching my video. And please send me an email if you have any doubts at mohan.indugul@gmail.com. Thank you. Bye.